Hello and good afternoon, and welcome to another Back to the Future recording this afternoon. I am here with Cambridge Consultants. So do you want to tell us a little bit about what you do and the work that you do in Agri-TechE?
Yeah, sure. Thanks, Becky. So I'm Niall Mottram. I lead Agri-TechE at Cambridge Consultants. What do Cambridge Consultants do? We actually develop technology. So not consultants in the traditional sense. We're all about trying to take scientific principles and then turn it into commercial products, which we do for clients who are both little and large, from small startups through to big multinational corporates that you'll know and love. And within the world of Agri-Tech, that's generally a split between people who are making equipment and the folks who are making the products that generally get sprayed or applied or planted through that equipment.
So I know that you, Cambridge Consultants, generally work across a whole raft of technologies. I think we couldn't list them all here. But what's been really exciting in the last 10 years? What's really changed the game, do you think?
I think within the world of Agri-Tech, I'll jump on that big theme of precision agriculture. So I mentioned that we're trying to marry the world of equipment with the world of chemistry and biology. And I think the way that precision ag-tech has evolved has been really interesting over the last 10 years. I mean, now we're at the point where spot spraying is starting to become a little bit more mainstream. We've got John Deere with See & Spray, and Case New Holland have got their products, and Agco have got their products. And that really only started to come about, goodness, 8 years ago, when the first few companies were talking about using clever machine vision based systems to recognize where you should spray and then being able to work out how you actually applied your active ingredient to that target. And that's been a fascinating space, not just that precision spraying, but then precision planting, and then a bit more precision about what's happening in the equipment. So I draw a distinction that it's not all about data. There'll be plenty of people who say it is all about data, and data is definitely part of it, but I think it's being able to react to the data in a way that benefits the farmer without them really being in the loop. So if I take something like a precision planter, that just does the job automatically. It has closed loop control, to use the geeky engineering term. And I think stuff like that just works and just makes the farmer's life easier. That side of precision agriculture has really made a big difference in the last 10 years. And ultimately, it should help farmers grow more using less, which I think is to everyone's benefit. It means you get more yield, more crop, and you use less inputs and therefore less cost in order to achieve it.
It's really quite amazing, isn't it? Can you imagine telling someone 10, 20 years ago they'd be able to, almost at plant level, like you say, treat them, plant them, manage them? It's really quite amazing.
Yeah.
So obviously, we're generally seeing a trend now move away from chemical inputs to perhaps biological inputs. And I know this is something you're really interested in. We obviously co-authored the paper earlier this year looking at some of the challenges around that. Would you like to just expand on your thoughts on biologicals?
I think I'd kind of class it into two groups. So we'll take biostimulants in one group and biocontrol in another. And maybe I'll start off on biostimulants first. So that's probably the more mature of the two segments, but at the same time, it's possibly the one that's got more of the image problem, because it wasn't as regulated as biocontrol is. There was kind of a mixture of the good, bad, and the ugly to a certain extent in biostimulants. And I think some of the good has probably suffered because of some of the ugly that's driven some reputational damage and a bit of preconceptions around biostimulants. So I think there's kind of work to be done to kind of repair reputations a little bit there, and hopefully the good products will succeed, because I think there's a lot of benefit to be had there, but there's clearly a bit of work. And then biocontrol is less mature, but possibly offers a bigger upside for the grower. Ultimately, this is all regulatory driven. Regulation, particularly Europe and to a certain extent here in the UK, increasingly kind of trying to move away from synthetic chemistry towards more environmentally sound treatments, and biologicals or biocontrol is definitely part of that. I do think there's a bit of a challenge, though, not to see it as drag and drop. You can't, if you like, substitute for glyphosate using a biological. As our report highlighted through the interviewees, by the very nature of something like glyphosate, it's non-selective. So you go through the field once and it's fantastic and it does its job. Biologicals by their nature are selective. So if you wanted to get the same overall impact, you might need to go through the field 3, 4, 5 times and spray 3, 4, or 5 different biologicals, almost like a recipe or a prescription that you would get from your doctor, taking something at regular intervals to make the problem go away. And that's both a challenge from a grower perspective, because if you're going through the field 5 times, then that's 5 times as much fuel and 5 times as much time, and you don't have the time and you probably don't have the money for the fuel. So how companies that are producing the biocontrol products, how they both get that communication message right, but then probably look to work with people on the equipment side to bridge that gap so it doesn't need to go through the field as many times, and we find a way of making it cost comparative with what's used today from a chemistry perspective. That to me is the next big challenge in biocontrol and biologicals, and hopefully we'll get there with the right kind of collaboration that the report alluded to.
It kind of goes back to what you were saying earlier with the sort of spot spraying and precision management. It just works, and we're just not quite at the point then that it just works. It takes a lot of learning to move over to biologicals.
Yeah, absolutely. I think it's good that you bring up that spot spray example, because I think that might be part of the solution. If we get technology that is really precise on the application side on spraying, then maybe you do get to a point where you selectively have different nozzles that apply a different biological and very precisely, and therefore you don't need to use as much across the field, and that might help with kind of regulatory compliance. But it'll also help from a cost perspective. If we're not having to spray everything, then there's clearly a potential saving there, and that needs to happen, because at the moment biologicals aren't cost competitive on a per acre basis with chemistry. So I think better system level thinking, how does that tie in with the equipment, probably needs to happen to make biologicals a success. I think most people want them to have.
That's really interesting, because I was just looking at how you can't always mix these biologicals in one tank, for example. So yeah, if you could feed in different things at different times, that's awesome.
Yeah, I mean, and I think also as we look to apply more living biologicals, so certain microbes that might release metabolites and so on, those are live cellular organisms, and if you put them through an existing nozzle today, they're probably not going to work out so well. There's shear forces there, there's pressure drops in the pumps and the pressure drop in the nozzle. So how do we redesign nozzles that are more tailored, if you like, to biology, to living things rather than just chemistry? And in doing so, more of that living organism hits the plant, releases its metabolite, kills the bugs. So I think that's where the right kind of system level thinking, where someone who makes equipment needs to talk to someone who's making biologicals and kind of work this out together. And that's one of the roles that we have, is being that bridge between biology and engineering, because we speak both languages. So how do we bring that together and design the right kind of modular equipment that should be cheap to retrofit to a sprayer, but then allows a grower to apply chemistry and biology in an effective and cost-effective manner.
Gosh, yeah, that's going to be a really interesting challenge. And like you say, just trying to think about how that end user is actually going to use it is quite complex, isn't it? But I think we'll get there. So if we can make this work, what do you think that's going to enable? How do you think the next 10 years are going to look?
I think it'll be fascinating. I think regulation obviously has a place to play, and obviously we've got new regulators in place now in the UK with the new government. I think how they actually understand what goes on at the farm gate level. I think there was an example highlighted where current regulation are based on concentration rather than overall coverage in a field. So actually, a spot spray device that would have high concentration on a certain area, from a legislative point of view today, is almost outlawed or is very restrictive. Whereas actually you want to be reducing the overall amount used per acre, where the legislation is actually different. So I think that's an example where technology has outpaced legislation, and legislation needs to catch up. And if it does, then I think it does unlock the greater use of biologicals, and it can't be seen as a stick to kind of beat the grower with. That just doesn't work. And quite understandably, there's been massive protests in the last year as a result of that. So how do the legislators have better lines of communication to those that they're impacting, and in doing so come up with the right kind of regulation that drives change, but not in a way that compromises the economics and the livelihood of the grower? So I like to think if we can get that bit a little bit more sorted, then you'll have a place where the technology is no longer kind of restricted by legislation, because legislation is caught up, and in doing so, it should become a lot easier to be adopted more broadly, and that should benefit us all.
So I guess we'll have to see how that progresses. But I can see, you need the enabling legislation to help you just take it away and run with it, really.
Yeah, and maybe the other bit from an enabler in the next 10 years is autonomy. So I mentioned that with current biologicals, you might need to go through the fields multiple times to get the same outcome that you get with traditional chemistry from a biocontrol perspective. If you've got an autonomous vehicle that's working at night and able to move at very precise speeds to do very precise application while the farmer gets some well-earned rest, suddenly the whole economics change, and we're not looking about the labor costs associated with multiple passes, or the fact that there just isn't enough hours in the day. And I think if we're looking at a 10-year horizon, I do think there will be autonomy of a certain extent on the farm. I look at all the big equipment manufacturers, they've all said by 2030 they want to have autonomous equipment on the farm. And I don't doubt that here we are in 2024, in 6 years' time, will it all be autonomous? No. But will certain processes be autonomous? Yes. And I think when that happens, then suddenly the economics changes for certain processes. And I think applying a biocontrol product, biological in that space, that would be part of it.
I think it could also be true that some of these living organisms, if that's what we're using, might work better at night, or they might work better in the rain, or whatever it is. And being able to use those technologies to make it more flexible actually would improve the efficacy of it.
Yeah, so, I think it is that whole system. You've got something that runs without a human in the loop, because it can run at any 24/7. You can pick and choose the best application windows, not what happens in being restricted by the weather, and then that kind of unlocks the biologicals, the biocontrol products accordingly.
So a whole systems change is what we're seeing in the next 10 years, is what I'm hearing there.
Big picture.
Let me get to work. Lovely. Thank you so much. It's been super awesome to talk to you today. And I'm really excited to see where this goes. And I think it's kind of inevitable. This is what we're going to move to in some way, shape or form. So I'll leave it up to you guys to make the technology happen so we can go and do it.
That's it. We're definitely here to be part of the overall solution. I appreciate the opportunity to talk, and thanks very much, Becky, and chat again soon.
Lovely. Cheers. Bye.
Bye.